So, hello friends, good evening. So, we just completed the 10th problem yesterday. We are going for the 11th problem. Yeah, only two of you are there, 3 of you attack this problem. So in such problems, you better list the variables that they have given you. Whatever variables they have given, you just have to correct them. There is no drawing or anything here. So it's purely manipulation. So they have given mass and they have given x of t. And they are asking you work done in 0 to 4 seconds. This is what they have asked. And they have given these two quantities. So you organize yourself. You just have to manipulate the variables using physics, whatever is the connecting physics here. Come on. So I would go for this. Work done would be half m into v of 4 square minus v of 0 square. But we have to go these two. This is the basic equation. So from x of t, we can get v of t, right? From x of t, we can get v of t. That is, if you differentiate function f of x of t, you will get v of t. Hello?
Yes, sir.
So that is how, just in these type of problems, you just list the variables and what is the basic equation you write, it will tell you what to do. Okay, so you get here v of t. If you differentiate that equation, you are going to get 3 minus 8t plus 3t square. I think we just have to find out v of 0, v of 4 and then do it. That's it. That's the problem. And substitute t is equal to 4. That's it. Correct?
Yes, sir.
Yes, sir.
That's all. So, going by that, we'll write half into 3 milligrams. So it is actually GM, no, it is milligrams. Misprinted it. So V4, you can do it by heart here. So 4 4s are 16, 16 into 3, 48. Then 4 8s are 32. So 16 to 3, it will be 19. 19 square minus V0 will be 3. So 3 square. So this is going to be the answer. Simple. So you will get this 1.5 into 19 square, you remember? 400.
361.
Excellent. Minus 9. So that gives you 1.5 into 361 minus 9 is 352. So you get here 15 twos are 30, 3 carry on. So 15 5s are 75, 78, and carry on, 15 3s are 45, 52. So 528. So if you write there, fine. Otherwise, you see the thing, these are all given millijoules, 520 millijoules. Okay, quite a simple problem.
Yes, sir.
But yes, you know, the data sometimes, you know, confuses, it takes you somewhere. It's all about, you know, how you organize the data using science. Okay, we'll go on to the next one. So the next sum is the 12th sum. A body moved along a straight line by a machine delivering constant power. The distance moved by the body in time t is proportional to. Button? You got C.
Yes.
Okay. You can others. Anybody else got the answer?
Sir, 1 minute.
Good. Basic strategy, please shoot.
Yes, yes. No.
Done. Good. Okay.
Yeah.
Yeah. Tell me now. Neatly tell me. I'll write on the board how you have solved.
Sir, P is equal to work done by times.
P is equal to your written.
Work done by times.
Okay. P is equal to, it is constant power, no? So
Yes.
P is equal to work
Done
done
by
by
time.
work done by time. How should I write it mathematically?
M into A into X by T. That
M
is
into
total displacement by time.
M into AX into by
X by T.
by T. Tell me like
Now,
this.
sir, X can be written as X by T square, sir.
X can be written as
A can be written as X by T square.
A can be written as X by T square.
Yes. Yes.
Wait.
That is initial velocity 0, initial.
Okay. A can be written as X by T square. Okay.
Yes.
So this becomes X square by T square. Okay.
PQ. PQ.
PQ. Okay.
No, sir, but the mass and power is constant, sir. We can make it.
So okay, fine. So you'll write it as X square is power proportional to TK. Okay. And
Sir, one
therefore
doubt, sir.
X is proportional. Wait, let me complete this. 3 by 2. You have written like this, isn't it? Hello? Hello?
Yes, sir, yes.
Now, okay, what is your doubt?
Sir, now to write it A as X by T square, sir, we need that initial velocity should be 0. We need that initial coordinate. Okay, sir, even if we take origin as the initial coordinate, then we should want that initial velocity at that point should be 0.
You can
Now they are
assume-
saying it is a machine giving constant power. and in time t sir.
You can
Then
assume. You
it
can
means
assume.
it should have some velocity at that
Why?
point.
Why? Why?
It
Why?
will not be zero.
Why? Why? I can have a
It
machine.
will not be zero is what I'm saying. Sir.
Correct, but it can also be zero, no? It can also be. They have not asked us to write any general equation. They have asked solution to some problem. Okay, they have asked them. So, see, if you want to get a general equation, assuming that you take all those things into consideration and create a general equation where initial velocity is u, then for a particular case where u is equal to 0 also, that equation must hold good. And what they have asked here is, in generally, what is the relation. So this should be the relation, that's it. There is no second thought about it. Okay, that's it. Okay, everybody understood this?
Yes, sir.
Somebody has got a better solution than this? I don't think there can be a better solution. Somebody solved it in some other method? Okay, fine. This is a simple solution. I appreciate it. So under constant power, one more relation that comes to me is F is proportional to 1 by V for constant power. Okay, so here also you can get it. F is equal to, again here, M into A and proportional to V, and V you can write it as, so here x by t, so t by x. Okay, and you can get the x here, so instead of A, you can again, as your friend has written here, A, here it becomes what? X by t square. So x square by t square. Okay, and I think rest of the things are same. Okay, that's also fine. Excellent. Okay, I don't think we have violated any conditions here. The body is moved along a straight line by a machine delivering constant power. But only one problem here is, what I notice in these things is that we are assuming that the acceleration is constant, and therefore we are able to write x is equal to half a t square. So this equation can be written provided x is, the acceleration is constant. Hello? But here you see, they have told it delivers constant power. So that means F into V is constant. Okay, F into V is constant. Or in other words, M into A into V is constant. But the question is, A can be a variable. A can vary with respect to time. Okay, then in that case it is not constant, so we may not be able to use this equation directly.
Sure, sir.
Although, yes please.
Sure, I'm writing A as x by t square. X is also varying. Y is also varying.
X is also? No, X automatically varies. See, you understand the meaning of constant acceleration. For constant acceleration, force.
They are actually not constant.
See, listen, force must be constant. See here, now assume that I have got a vehicle, I am going with some constant power. I can increase the speed. Okay, you see, the engine works like that. Understand the mechanism of the engine. See here, it is the product of F and V. What do you mean product of F and V is constant? If F increases, speed increases. See, in the geared vehicles, so here F can be variable. There is nothing to suggest that F is constant. If F is constant only, then A is constant. So anyway, you got the answer here for this. It appears to be 3 by 2. Okay, but nonetheless, the way we have solved it is wrong. Okay, so yes, please.
Yes, so we can use dimension analysis.
Which analysis?
Dimension, so we can write dimension of acceleration, sir. And then we can write it as x by t square.
We can use dimension analysis and do that.
Yes,
okay,
sir.
Even though.
Then we don't have to consider that acceleration has to be constant.
Okay, the distance moved by the body in time t. How will you get that thing here? Tell me.
Same formula, sir.
Okay, so you go with this formula. You're telling is you start with this formula. Okay, you start with this formula. Then what will you do?
We'll write the dimensions, sir. So mass will only be m, sir. Acceleration we can write it as x and x into t or minus 2, sir.
So you will write this dimension, and also
Yes,
the dimension on the left hand side. Okay,
Yes.
and then you want to flow it. Okay, that's also good technique. Done. That is okay. I mean, it's not violating any condition. Right. Okay. Appreciate it. Okay. So therefore, for these things, if you want to take that into this one and solve, then you see this solution.
They have done it by integration.
Okay, yeah, they are done it by integration or differentiation. That is not the thing. Just I have given you some solution. Look at that.
Yes.
So here acceleration is written as a dv by dt. So it's a constant c, and then they have integrated it. So getting v square dt, v is equal to under root 2c by m t, etc. etc. They get it. So this is the right solution, because here you see, even though you got the answer right, but you have missed out the basic thing there. Okay. So those are all the pitfalls here. So you have to be very careful when you use the, see what happens is our initial chapters have been on motion in one dimension, constant acceleration, because from 8th standard, we start using the equation v is equal to u plus at, and in the first quarter of PUC first year also we continue to use that, and then we are introduced to variable acceleration. Okay, but somehow old habits die hard, so we tend to go by that. So you have to, you have to control yourself and ensure that that you will not commit this mistake again. Okay? Hello?
Yes, sir.
Yeah, done.
Yes, sir.
So you see, we have to learn from whatever we are doing, and that is precisely the objective of this program. At least start making the beginning, properly. So I think the first thing you should do is draw a circle. A particle of mass m is moving in a circular path. So path is particle m, circular path of radius r. Such that's a centripetal acceleration. The centripetal acceleration AC, centripetal acceleration AC is varying as k square r t square. Power delivered to the particle by the force acting on it. Okay. So centripetal acceleration is a function of time, and here you see the centripetal acceleration is increasing with time. Okay friends, what will be the power delivered if the body is moving with constant speed? Hello? if instead of this, if the body particle was moving with constant speed, then what is the power delivered? How will it? Huh?
0.
0, isn't it?
Yes.
It is 0.
Yes.
Okay. So,
Yeah.
but if the particle is moving with variable velocity, then do you need power, external power? You need, isn't it? Because the velocity has to change.
Yes, sir. Tangent.
See, this velocity has to change. This velocity has to change. Correct? See, here this velocity has to change. It is not constant. This velocity is, this speed is not constant. Okay, so that should give you the clue. So that should,
one doubt, sir. Tangential acceleration is responsible for the speed of the particles.
Excellent.
And,
Correct.
centripetal.
So here that's a good thing. So that means you have to attack this problem very clearly, that there is tangential speed. If I take the tangential speed, okay, this tangential speed you have to take, because it is not constant. Tangential speed is in this case a function of time. Hello? Tangential speed
It is not natural. What can only affect centripetal acceleration?
Hello, here you see, here centripetal acceleration is a function of time. And what is it happening here? As time increases, centripetal acceleration is increasing. So centripetal acceleration is related to what? V tangential square by r. Isn't it? So if the centripetal acceleration is increasing, Vt is also increasing. Right? Vt is also increasing.
Yes, sir.
So that should give us the clue, and we should be able to solve this problem. So I think I give you the hint here. So straight away this equation AC itself, you write it as tangential acceleration square by r is equal to k square r t square. Then straight away write this equation. So this gives you what? This gives you Vt square is equal to k square r square t square. They are asking you the power derivative. So get the power delivered. So here from this, if you can get AT, tangential acceleration. Tangential acceleration. See, tangential acceleration here, you got here Vt square. So if you differentiate Vt square, if you differentiate Vt square, Vt.
You can simply take root on both sides, sir. All are square term. You get KRT and differentiate KR. You get directly.
So you can write it here, Vt is equal to KRT. And if you differentiate Vt, then straight away you will get it Kt. Kt is equal to Kr.
Yes, sir.
Correct. So At is equal to Kr, and At means it is okay. Multiply both sides by m, multiply both sides by m.
Here we are getting that the tangential force is not changing, sir.
No, tangential force is changing or not by, you just multiply it by m. So what are you getting here? Tangential force. Hello? You are getting tangential force. Then this tangential force, you multiply it by Vt on both sides. Okay. So then this becomes the power delivery. This becomes the power delivery. You don't need, the power is delivered to increase that velocity, isn't it? So directly this you get this power. So you can knock off this m here. Okay. And write the value.
Now the force acting is also affecting the centripetal acceleration. Won't there be power generated?
That's all.
Because of the change.
Basically, I asked you that question only initially. That's why I asked you that question. Okay. I asked you that question very initially only. Right? So I asked you that question. See, now here if it is going like this, if you say there is some power, so that means force should act in this direction and the displacement is in this direction. So this force will not do any work. Okay, it will not do any work. So you don't need power to keep it in the path. Okay. So therefore here we have got the right equations here. Here Vt square is equal to, we got there k square r square t square, and therefore we get Vt is equal to kRt, right? And then we multiply both sides by, we have got Vt here. If you differentiate this, you are going to get kT, so that will be equal to kr. And now multiply both sides by m, so this becomes the tangential force. Okay, and then tangential force into multiply both sides by velocity, tangential velocity. Okay, so this becomes the power. Okay, so then here you have got here m k r, and now what is Vt? So Vt is root of this. Vt is k r t, right? So multiply this. So here m k square r square t square. This is the power delivered to the machine. Yes, you have this option. R square t square. You have the option. Only t, sorry, not t square. So option A is the, option B is the right option. Okay?
Yes.
That's it. So the thing here is like this. AC they had given, and then since AC is varying, so that means the tangential velocity is varying. So tangential velocity is varying means there has to be force acting, and if it is delivered by a machine, then it has to expend power, and that's how things develop here. Okay? Hello?
Yes, sir.
Yes, sir.
Done. Okay. So we'll move on. Anushri,
Yes, sir.
why did you not join yesterday?
There was network problems.
You should have sent a message, no? Huh? See.
Sorry, sir.
Sorry alla, ನೋಡಿ ಎಲ್ಲಾರ್ಗೂ ವೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಾನು. ಇಲ್ಲಿ ನಿಮ್ದ ಟೈಮ್ ಎಷ್ಟಾಗ್ತದ? ನಿನಗೋಸ್ಕರ ವೇಟ್, ಇನ್ನೊಬ್ಬರಿಗೋಸ್ಕರ ವೇಟ್, at least ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಕಳಿಸ್ಬಿಟ್ರೆ it's fine. But where is your friend Aditi? How come? So the potential energy U. Yeah, this is again a very basic problem. X1 is stable equilibrium. Definitely not. Isn't it? What is the condition for stable equilibrium? Sorry, what is the condition for equilibrium first? Hello?
The net external force acting on it should be 0.
So how will you get net external force in this case? If you are given the potential energy curve, if you are given u of x, then how will you get the net force from this? Isn't it? So F external force will be minus dou u by dou x.
Yes, sir.
This is the basic equation.
Yes, sir.
So now here, if net has to be 0, F net has to be 0, then the slope should be 0. So there is only one point where the slope is 0, isn't it? There is one point where the slope is 0. This is the point where the slope is 0. But this point is for what? Equilibrium condition. Okay, so there is a difference between equilibrium and stable equilibrium. So equilibrium is net force must be 0, net torque must be 0. But for stable equilibrium, one more condition is there. What is that condition?
The curve should be concave upwards.
Okay, fine, that is one way to visualize. But the most important
Slope of
thing
the
is,
slope.
yes, if you see the slope on both sides, that means now if you give a small disturbance, there should be a tendency for the particle to come back to its original position or the mean position. So in this case, it cannot happen. So therefore, XY A is wrong, B is also wrong, C is also wrong. So D should be the option.
Yes, sir.
Okay. Supposing this curve was extended like this, then you could have said, well, this is the point of stability.
Yes, sir.
Okay.
Yes, sir.
Now, solve fundamental problem questions.
Done.
Basic definition of potential energy. You should not take so much time for this. Basic question it is. So what is potential energy? Hello?
Work done against a conservative force field is stored as potential energy.
Yes, that is the right decision. So it is the work done by external forces against the, on a body or a particle, against the conservative forces. Okay, now apply that here. So come on, what will you do here? I give you the hint. So if you go from infinity
The
and
conservative force means
if you go from infinity and start coming towards, that is, you know, say there is something here and there is something here. Okay, now assume that mass also, mass or charge, whatever it is. And if you are coming in this direction and the potential energy keeps increasing. Hello? Hello?
Yes, sir.
Okay, I'll not say M here. There is some quantity A and A, some physical quantity. If you are bringing it from R equal to infinity like this, and if the potential energy is increasing, that means when the body is here, the force is in this direction. The force to this is in this direction. Okay, the force due to A on A is in this direction. So therefore there is repulsion. So if you are traveling from infinity and if you are coming and if the potential energy is increasing as it is increasing from F to E. So if you are traveling like that, so if you are first entering the position F, then crossing that and coming to E, the potential energy is increasing there. So therefore EF should be a zone of what? Of repulsion. EF should be a zone of repulsion. Okay. B and D are equilibrium position, wrong. C is a point of stable equilibrium, correct. The force of interaction between two particles is attractive between C and D. Yeah, between C and D. If you are going from C towards D, okay, or you are coming from D towards C, and if the potential energy is decreasing, okay, that means the particle is getting attracted and you are going to pull the particle on the other side. So therefore CD should be a region of attraction.
Yes.
And repulsion between D and D, wrong, it is something different. So third is not the option. Fourth one, the force of interaction between the particles repulsion between E and F, that we have done. So therefore it is the option number 2 and 4. So C is the right answer.
Yes, sir.
Correct? Everybody got that?
Yes, sir.
Right. So C is the right option. Okay. So the basic question. So you see the basic concepts. You know how they can coin questions and you know they can 15 1. Yeah, this is a good problem. Take some time and solve it, all of you. Correctly understand the problem and solve. Draw the free body diagram. Spring this.
Yes.
And then examine very carefully. And use some logic also. So this is the condition first, where the length of this spring is going to be L naught plus some x. Mass is m, is mg. So now we are going to do like this. So here there is mg up to down, and of course I have got to show here tension is equal to spring force kx. Correct? This also is mentioned. So in the second case, there is again some tension, and also the external force applied by the ball. This is the external force applied by the ball. Hello?
Yes.
So now supposing the spring was not there. In it, this is elongated by, okay, I will take it as some delta x, that is better, delta x. So this is elongated by delta x, no doubt. So now supposing this force F was not there, okay, then the work done would have been simply they are asking for then the gain in the potential energy. So the gain in the potential energy, if this boy was not, if the spring was not there, okay, gain in potential energy, no spring, okay, then it would have been mg into delta x. Correct? Hello?
Yes, sir.
But what is happening here is, you see here, that means now the potential energy that he is gaining is integration of F dx, where F is the force applied by the boy in the upward direction. Hello? And he says slowly, that means he is not allowing the kinetic energy to increase, that means the net force on the body is 0 throughout the journey. You should appreciate it. So here the gain in the potential energy will be F dx, and in the first case this is simply going to be mg into delta x. Okay, but however, now if you take the spring into consideration, the force that he has to apply will be less, because the spring already it is giving some force pulling it in the upward direction. Agreed?
Yes, sir.
Yes, sir.
So therefore, with the spring, see, without the spring you are going to get this. With the spring, this F dx will definitely be smaller than this. Agreed?
Yes.
Yes, sir.
And now you see the spring force and the gravitational force. These two are conservative forces.
Yes.
Conservative forces, and therefore, if as you go up, the spring will lose some energy. The spring will lose the potential energy. Okay. Now, where does that go? Right? Where does that potential energy go? Right? It should be given to the mass, which is gone up. Clear?
Yes.
So therefore, you see this option A, work done by the boy against the gravitational force element. No, not correct. Why it is not correct? Because there is spring action. Okay. The loss of the stored energy by the spring minus the work done by the tension in the spring. No, it has no meaning. The work done on the weight by the boy, okay, that is F into dx, plus the stored energy lost by the spring. That appears to be right. Okay. Option D, the work done on the weight by the body minus the work done by the tension in the spring plus the stored energy, no, quite common. So I will go with C. Hello?
Yes.
What do you think?
Yes, sir. Great.
Correct now? 16th one? Isn't it? Hello, did you understand?
Yes, sir.
See, now
Yes.
I see. I wrote the diagram here, and then if I don't have the spring, then simply this is going to be the thing. But with the spring, because already the spring is pulling up, I have to apply very minimum force to push it up. So my work done with the spring will be less. But again, you see that spring force and gravitational force are conservative forces. Therefore, the energy must be somewhere. And they are told slowly. That means kinetic energy is not increasing. And therefore, this is how it should happen. So C is the option. Okay? Right? Shall we go to the next problem?
Yes, sir.
Yeah. The rope ladder will then carry mass attached to the basket of a balloon of mass. Please get hold of the problem here by drawing some drawings and things like that. See, you should learn science through this. Okay? And as you are learning, applying science, skills will develop. Don't simply look at some answers and be happy. See, as you work, your brain power will increase, skills will increase, science perfection will increase. But genuinely you should work. You should work for the purpose of learning science, not for the purpose of passing exam. So I will draw a balloon, and this balloon will have what is called as the buoyant force, and then they are told it has got a basket. Is a basket, and then there is a ladder. So here there is it, and the mass of this whole thing, they are told is m, and the mass of this curve is m. And what else are they told? The length of the ladder. This length is ladder, and the system is in equilibrium. And the man climbs up the ladder, the balloon descends by height. So I will create the realistic position here. So we call this H. So here, okay, what are the basic concepts that you will consider here? If you identify the concepts involved in this problem, then you can solve the problem. What is the underlying science in the concept that are being used here? See, when he is climbing up, okay, you understand the mechanism. When you climb something up, what do? You hold something like this, and then you pull it down, so your legs get released. Then you keep the leg at the next level. Hello?
Yes, sir. Yes.
Yes, sir.
And then what you do, your leg goes at the next level, then you press with the leg, your hands become free, then you go to the next level, correct?
Yes, sir. Yes.
So here you are exerting force on the rope, okay, and by Newton's third law, the rope will exert force on you, right?
Yes, sir.
And now in this case you are a part of the system, and therefore whatever you are doing is internal. So the force that is acting between you and the ladder and all, becomes internal in nature. No external force is involved. Hello?
Yes, sir.
So external force is not doing work and the velocity of the system is not increasing. Clear? External force is not doing work and the velocity of the system is not increasing. Okay? But definitely the man is going up. The man is going up. So the potential, so with respect to ground, the man is going up. So therefore the potential energy of the man is increasing. That is no doubt about it.
Yes, sir.
Then, what is the next thing that I should tell you? See, this is system of particles.
Energy.
Energy is conserved, correct? The potential energy is conserved here. Okay, the potential energy is conserved. That means how you write it mathematically now. That is increase in the potential energy of the man, right? So increase in the potential energy of the man is equal to what? Decrease in the potential energy of M. Isn't it? Hello?
Yes, sir.
Increase in the potential of man is equal to decrease in the potential energy of the whole system. That is, the system, system will come down, we will go. That is what will happen. So instead of taking this ground level here, you can even take this as a reference. Even this you can take it as a reference. That means now if the man comes to this point, so the man comes to this point, say some distance he climbs y, some distance delta y he climbs. Okay, assume that he climbs by delta y, then this whole system has to come down by the same, by a proportional amount. So if he climbs up, mg delta y is the gain in the energy of the person if he comes up. This should be equal to the decrease in the, see the potential energy of the system will be what? Mg into capital Mg into L. So capital Mg into, it will come down by some amount. This system will come down by some amount, isn't it? See, this person has gone from here to here, so his potential energy has increased by so much. Okay, and this much it should decrease by, this thing will come down by some amount. Got it?
Yes.
So that means now that will come down by, see, capital Mg by, you give someone, see, you give the name here delta Ym, and here you give the name delta y m. So you can establish the relation between these two. So G's will cancel. So here did you understand? Hello?
Yes, sir.
What is your next step now? See, understand the mechanism. So he anyway, see, he would keep going up. But because this has gone up now here, this system has come down. This system has come down by this much height. So this is what I call it as delta y capital M, right? And this is what I am calling it as delta y m. Anyway, this fellow will travel L distance, no? Hello?
Yes, sir.
This person will travel L distance.
Sir, no.
No, he will climb L distance up.
Okay. Yes, sir.
But the potential energy will automatically decrease. Understood? So he will climb the distance L. He will keep climbing. Not distance F, he will climb L level. But at the same time, as he is climbing, the system itself is coming down.
Yes, sir.
So for every delta ym climb, hello, the mass is the upper, the whole system is coming down by delta y.
Yes, sir.
So here you see delta ym, if you find out. Okay, so delta ym for delta ym, therefore for length L. So what is this? So this is the total height by which this will come down. Got it? This is going to give you the height, the total. See, as he is climbing up L distance up, the whole system is coming down by this much height. Did you get this?
Yes, sir.
Yes, sir. Yes, sir.
So therefore now see, if this balloon system was not there and it was a simple ladder, then his potential energy would have increased by mgl. Okay. Now
Yes, sir.
it is decreased by this quantity. And ym by ym here, y capital M by small m is small m by capital M, isn't it? See here, this is equal to what? Ym by ym, y capital M by y small m
Yes,
is equal to what? Is equal to small m by capital M, no? Hello, isn't it? Isn't it? So, if he climbs L, he will come down by this much height. He will come down by this much height. So, therefore, his potential energy will decrease by m the potential man. Students, did you get it? See, if he see, he will ascend up. Say, he will ascend up. He will come from here to here, but the system itself will come down by this much height. So, if the system had not come down, then his potential energy would have straight away increased by so much. Now it is going to decrease by some amount. How much amount it is going to decrease?
Some height h that way he will ascend.
And they have told here the balloon descends by height. Hello, sorry. So the balloon, this one they have told is height. Isn't it? The balloon descends by height. Hello.
Yes.
They are given this. So therefore, he will just descend by this height. Therefore, the answer is mg into L minus h. I had not seen this h. I was trying to study.
Yes, sir.
Yeah, this is what it is. So, option A increases by mg into L minus h. Is the option. Okay?
Yes, sir.
So it's all like this, understand the mechanism and enjoy working with these numericals. Your brain power will increase, and that is an asset. Your science knowledge will increase, your brain power will increase, your attitude will increase. 100% when you become professionals, this brain power, increased brain power is what is going to help you. You may not remember any of the PUC subjects. I am telling you, I have gone through all this process. I am a trained engineer. I know what happens. So you may not remember, but now you know the effort that you are putting, your vikas par hai, tumhara brain power develop ho raha hai. And throughout your life, as long as you want to work, you have to keep learning. Because what was yesterday is not today. Okay, so therefore, if you want to be a learner for life, then you have to learn how to learn. Okay, and for that, confidence is important. Please do that. God bless you. Okay, it is already 9:10. I will stop the class.